Well, one instance that they could be used is that and students sometimes will make these problems harder than they need to be because they'll sit there and try to figure out what x and y are, get it some kind of decimal, and then try to use that to come up with an answer that would be you rounding off a lot of things and not be quite as close to an answer to the answer that was sought. We're being told here that we have log base 5 of x equals 1.3 and let log base 5 of y equals 2.1. Could we use processes we've already talked about to find out what x and y are? Sure. However, more than likely, they're not going to be, um, you know, rational answers, and therefore you'd have to round them off somewhere, and that's where some of the issue would lie. Where you were expecting a very simple answer, you're going to have an answer that looks more irrational, would generally be pretty close to the answer, depending on how many times you rounded during the process of doing the problem. But would be not quite as exact as the answer that we're looking for. So I'm going to use the properties here. I have a single logarithm of a product of three different things in A. So what I can do with this is, and I'm going to keep in mind that I have those two logarithms up there. And what I'm trying to do is get log base 5 of x and log base 5 of y to show up so I can replace them with 1.3 and 2.1 respectfully. So that in part A, I could turn that into the sum of three different log base 5s. I have the log base 5 of 25, I have the log base 5 of x cubed, and I have the log base 5 of y. The log base 5 of 25 is something that we should really know. I mean, we're going to get to that point in a second, though, but I can also write 25 as 5 squared. The middle one, log base 5 of x cubed, because of the power property or the exponent rule for logarithms, I can move that exponent in front and make it a multiplication. So I have 3 times the log base 5 of x plus the log base 5 of y, which I have these in parentheses because I know I'm going to do a substitution. Where I see log base 5 of x, I'm going to replace it with 1.3. Where I see log base 5 of y, I'm going to replace it with 2.1. So notice I'm not replacing x with 1.3 and y with 2.1 because that isn't what we were told. That's what I see a lot of students sometimes do with these. They'll say, I'll say log base 5 of x equals 1.3, and when they see log base 5 of x show up in the problem, they say log base 5 of 1.3. That isn't what you were told. The log base 5 of x is 1.3. So I'm going to replace log base 5 of x with 1.3. I'm going to replace log base 5 of y with 2.1. The log base 5 of 5 to the second power, well, I'm taking a logarithm of an exponential with the same bases. They cancel, so I left with 2. So I essentially have here 2 plus 3 times 1.3 plus 2.1, which becomes this. And when I add it all together, it becomes 8. Now, if you went through a process to figure out what x and y were and then solve this problem out, you would get an answer, depending on how many times you rounded during the process of doing that, would be pretty close to 8, but wouldn't be 8 exactly. And here we're expecting an exact answer of 8. And there is a way of getting it, so be aware of that.